So we start off graphing 1 minus 4 cosine theta. First thing I need to do is decide what type of graph it is. To make that decision, we're looking at the A and the B value and looking at the back of our unit circle, which is this thing right here. So A and B, 1 and 4, are they equal numbers? No, so it's not like the last one. The last one was a cardioid. Is A greater than B, or is A less than B? Less than B, that makes this one a Limacon with a loop. Okay, this one's going to be a little bit weird when we graph it, but it is a Limacon with a loop. We don't need that anymore, but this makes it a Limacon with a loop. A and B. A is less than B. Next thing we make a decision on is symmetry. Jalen, what type of graph is it? Is it a sine or a cosine graph? It's cosine because it says it right there. It's cosine. When you think cosine, Jalen, are you thinking X or Y? X. So this graph has X-axis symmetry. So if a graph has X-axis symmetry, you're going to fold it over this line right here. That's my X-axis. So with your hands, show me, is this an alligator graph or a butterfly graph? Alligator. We can fold it down. Okay? We go to our next spot, which is finding the maximum. So remember how to find the maximum. We're using this equation right here, 1 minus 4 times something. We are plugging something in for cosine here. What number do we want to plug in for cosine that makes that answer as big as possible? It's either 1 or -1, and I hear lots of -1s. Why do we want a -1? To make it a positive, because it's a -4 times -1. That changes it into 1 plus 4, which makes my maximum to be 5. So my graph, when I graph it over here, is going to go all the way out to the 5th ring. It's going to go all the way out to the 5th radius there. When is that going to happen? Well, I need to look on my unit circle for when cosine gets me -1. So go to my unit circle and find cosine being -1. So I'm looking for X or Y. I'm looking where the X is -1. It's either at 0, 90, 180, or 270. At 180, my X is -1. So 180 degrees is what I want here. So my first point that I can make on my graph is at 580 degrees. There's my first dot. Okay? I only need to know, do I need to know a side, like the left or the right, or do I need to know the top or the bottom? The top or the bottom, because we said this is an alligator graph, we're going to fold it over. So I'm going to figure out what these numbers are, and then I'm going to fold them down. Okay? So I'm right here at 180 right now. I'm going to work my way around, plugging in the numbers, until I go all the way back to 0. So we're doing the same thing we did earlier. We're plugging into that equation, 1 minus 4 times something. Okay? Do I want to plug in the X value at 150 degrees on your unit circle? So you're going to 150 and looking at your X value. Do you want to plug in negative radical 3 over 2? So I am not going to use 150 degrees. Next comes to 135. Do I want to do cosine at 135? Do I want to use negative radical 2 over 2? Then I get to 120. Do I want to do cosine at 120? Do I want to use -1/2? That's not a crazy number, so we're going to use -1/2. So at 120 degrees, I'm going to plug in my X value of -1/2 and see what I get. Okay? So we're using our brain. 1, negative times a negative. Is that a positive or a negative sign? 1 plus, what's half of 4? So this value is 3. So at 120 degrees, I need to graph the point of 3. Okay, every time we do this, at most, you're going to graph 5 points. We've graphed 2 already. We need to find 3 more. Okay, we just did 120. Let's go to 90 next. Should I use 90 degrees? I can do 90 degrees. 90 degrees, we're plugging into that equation. 1 minus 4 times something. What is cosine? What's our x value at 90 degrees? It's 0. I'm looking at the x. At 90 degrees, it's 0. So I plug in 0. I get 1 minus 4 times 0, so 1 minus 0. So what's my radius going to be? 1. So at 90 degrees, I make a dot at 1. So we use 90. Keep working. I go around. I'm just doing a loop here. Next one to come across is 60 degrees. Zach, do I want to use 60 degrees here? Yeah, because what's my x value? 1/2. Good. Because it's an easy x value of 1/2, we're going to use 60 degrees. Okay, so Zach says, yep, plug in that x value of 1/2. It's 1 minus, what's half of 4? 1 minus 2. -1. So a little bit trickier to graph, but not impossible. 60, -1. Well, here's 60 right here. Here's 61 right there, but that's not where my dot's going to go. Remember, when it's a negative radius, we go straight across to the other side of the graph. So it's really at 240. Remember, we start here at this place, and we go across to the other side. Okay, so we did 60 degrees. We used that one. We're going to keep going. Josh, do you want to use 45 degrees here? Why not? It's got a radical in it. So what about 30 degrees? Do I want to do cosine at 30 degrees? No, because it has a radical in it. What about cosine at 0 degrees? Yeah, we can do that, he says. At 0 degrees, what is my x value going to be? What am I going to plug in? It's 1. I look at my unit circle. At 0 degrees, my x value is 1. So 1 minus 4, my radius is going to be -3. So here's 0, 3 right there, but that's not where my dot needs to be. What do I do for -3? Go to the other side. So I'm going to go to 180 degrees and put my dot right there. There's some weird dots going on, isn't there? Okay, why is it weird dots? What's our shape? It's got a loop in it. The loop is what makes this weird. Okay, I went around and I graphed my dots. Now I'm going to start flipping them over the y-axis or over the x-axis. This red dot, do I need to flip it? Nope. This blue dot right here, it's 120. What is that blue dot going to become when I flip it? 240, because I'm flipping it down over. Remember, it's an alligator graph, so I'm flipping it down. So this point right here becomes 240. So 3, 240. Bless you. I got my green dot right here. I'm flipping it down. So where's it going to be when I flip it down? 270. I've got this purple dot right here. I'm going to flip it up. So it's at 240. So now it's going to be at, I'm going to flip it up. So it's at 120. This dot right here, I'm flipping it straight up. It was below the axis, so now I got to flip it up. The rest of them I flipped down, but this one I got to flip up because it was on the bottom, so it flips up to there. And then the orange dot can't be flipped. It looks really awkward. Even looking at it there, you don't know what's going on. To get the best picture, that's why we use our graphing calculator. So turn it on, hit the y equals button here in the corner, clear out what was written, and I'm going to type in my new equation. So my equation is 1 minus 4 sine theta. Oh, is it cosine? Sorry, thank you. 1 minus 4 cosine theta. Close. Watch it closely. Once you've typed it in, let's check the board here, please. So watch what happens when I hit the graph button. It'll show you what it does. It goes around and makes that loop. Okay, watch it again here. This is how you got to make it. Retype it. Nope, not like that. It goes around and makes that loop. Okay, it's a little bit hard to do. Here's how I like to do it. I color code it. I'm lucky I've got cool colors that I can color code it. But watch how I connect it. I'm going to do it in the same order that I did before. I start at the red. I go around the outside and make the big loop. So red to blue to green. Okay? Then I'm going across to purple to orange to purple to green to blue back to red. Okay, let me show you again. So I go around the outside. I hit that green. Then I start to do my loop. Go down to the center, around, back out, back to the top. It's weird. Get your picture to look like what your graph is. If you can't do the dots, that's fine. But look at your graph and make sure you can follow what's going on.